Hello, today we are going to multiply and divide by powers of 10. Take a look at the following. We have 10 squared, which is the same as 10 times 10, which equals 100. When we have 10 to the fifth, that means we have 10 times 10 times 10 times 10 times 10, and that equals 100,000. What do you think the small raised number means? Well, when it's 10 to the second power, I notice we have two tens and we also have two zeros. When we have 10 to the fifth, we have 1, 2, 3, 4, 5 tens multiplied together, and our answer has 5 zeros. So this little number in the corner, which is called an exponent, is the number of times we are multiplying the base by itself. So for a similar number sentence for 10 to the sixth, we would have 10 times 10 times 10 times 10 times 10 times 10, or 6 groups of 10 multiplied by itself. So it's not 6 times 10, but it's 10 times 10 times 10 times 10 times 10 times 10. So here you can more easily see how we have 10 to the first, which means we just have one 10. 10 to the second, or 10 squared, is the same thing as doing 10 times 10. 10 to the third, 10 times 10 times 10. 10 to the fourth, 10 times 10 times 10 times 10. And 10 to the fifth. This pattern would continue depending on the exponent. So today we are going to learn how to multiply by a power of 10 and divide by a power of 10. And we're going to see that there's a trick. So you may take a moment to pause this slide to read it, but we'll revisit this at the end. This is the trick that will help us to both multiply and divide by powers of 10. So let's break it down. If we have 4 times 10, our answer gets bigger. We end up with an answer of 40. Then we have 400. Then 4,000. 23 times 10 gave us a product of 230. Then we have 2,300. And then 23,000. And don't forget, we need to do number, comma. So every time we multiplied by 10, we added a 0. But what that really means is that the digit 4 moved over on our place value chart. So when it started in the ones place, it moved to the tens. When it was in the ones place and it was multiplied by 100, it moved over 2 place value spots or 3 place value spots. But what does that mean with decimals? If we have 4 and 3/10 times 10, our answer ends up being 43. If we have 4 and 3/10 times 100, our answer is 430. 4 and 3/10 times 1,000, our answer is 4,300. We didn't just add zeros. So what happened was, similar to the slide before, our numbers moved over on the place value chart. So when we just multiplied by 10, when our 4 was in the 1 spot, it moved over to the 10th spot. And when our 3 was in the 10th spot, it moved over 1 place value spot to the 1s. So essentially a trick is if our decimal was between the 4 and the 3, we moved the decimal over 1 time. For 4.3 times 100, it moved over 2 times. When it was 4.3 times 1,000, it moved over 1, 2, 3 times. Remember, all numbers have an imaginary decimal at the end. The same thing is going to happen when we have a power of 10. This exponent is going to tell us the number of times to move that decimal over. So if our beginning number, or one of our factors, is 4 3/10, I'm going to write just my digits, 4 and 3, and I'm going to place my pencil in between exactly where the decimal would be. If it's 10 to the first, I'm going to move that decimal over one time and add my decimal. You can either write this as 43, or you can put that decimal if you'd like it to keep track. For the next problem, we have our 4 and 3. First, write your digits. Put your pencil where the decimal would be. Since we're multiplying by 10 to the power of 2, or 10 squared, that decimal is going to move over 2 times, which means we need to put a 0 as a placeholder. For 4.3 times 10 to the third, we're going to write our digits 4, 3, put our marker pencil where that decimal would be. We need to move that decimal over 3 times, 1, 2, 3. So we need to fill it with 2 zeros and then go back and add our comma. 2.9 times 10. So in both examples, 10 is equivalent to 10 to the first power, 100 is 10 to the second power, and 1,000 is 10 to the third. That's going to let us know how many times we need to move that decimal over to the right. We're moving it to the right because we are multiplying. So 2 95 hundredths times 10. First thing, write your digits, 2, 9, and 5, and put your pencil or your marker exactly where the decimal would be. Since we're multiplying by 10, we're just moving it over one time, so our decimal is now in between the 9 and the 5. That would be the same thing for 2 95 hundredths times 10 to the first. We put our decimal in between the 2 and the 9 where it began. We're just moving it over one spot, so our new decimal spot is between the 9 and the 5, so 29 5/10. For 2 95 hundredths times 100, we need to move it over 2 times. So we end up with an answer of 295. Times 1,000, or times 10 to the third, watch what's going to happen. So first, put down your 3 digits. Put your pencil where you started. 1, 2, 3. So we need to add a 0. And the same thing would be true if we're multiplying by 10 to the third. It's the same thing as 1,000. 1, 2, 3. Add a 0, number, 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 comma. When we divide, we go the opposite direction. So we're actually going to go to the left. So instead of starting with a 4 and going to the right, every number has an imaginary decimal at the end of it all the way to the right. When we divide by 10, we're going to move it the opposite direction. So we end up with an answer of 4/10, or 0.4. We can write 0.4 if we'd like, but that's the same thing as saying 0.4. 4 divided by 100, put your digit 4. We're going to move it twice, so we need to add an imaginary 0 here. Put a decimal, and again, just for formality, we add that 0 in the front so that our answer is 4 hundredths. And our last one is 4 divided by 1,000, which, if we think about fractions like division, that's the same as saying 4 divided by 1,000, or 4 thousandths. We're going to end up with that decimal of 4 thousandths. 1, 2, 3. And we get the decimal version of that fraction of 4 thousandths. Same thing with 23 divided by 10. So put your 2 and your 3, put your imaginary decimal at the end. We're moving it over one time, so we get an answer of 2.3, or 2 3/10. 23 divided by 100. 1, 2. Put our decimal at the beginning. Again, add that 0 at the beginning for formality. And just to be formal, I mean 1, 2, 3. We end up with 23 thousandths, which again is that same equivalent 23 thousandths equivalent decimal just like that. So if we have it by a power of 10 or just that number in standard notation, we always first start with writing our digits. Put your pencil where the imaginary decimal would be. Since we're dividing, we're going to move to the left. Our number is going to get smaller. If we're dividing by 10, we're moving it one time. So our answer is 43 hundredths. Get that same answer here. The top and the bottom are the exact same problems, just written in exponential notation. 4 and 3/10 divided by 100. Put your imaginary decimal between the 4 and the 3. We're going to move it over 2 times, so we need to add that imaginary 0. And if it's 4 and 3/10 divided by 1,000, put your imaginary decimal 1, 2, 3 times. And these top numbers would be the same here. 2 and 95 hundredths, we can skip the top. Let's move straight to just exponential notation. So I'm going to write my digits 295, put my imaginary decimal between the 2 and the 9. If I'm dividing by 10 to the first, I just move over 1 time. So my decimal goes here, and then add that 0. 2 and 95 hundredths, put your decimal here. From dividing it by 10 to the second, move it over twice. And if we're dividing it by 10 to the third, we're going to move it 3 times. 1, 2, 3. So let's put it all together. Let's multiply first. So in our first problem, 14 and 57 hundredths, first things first, write down your digits. Put your pencil where the decimal would be. We're multiplying, so we are going to move to the right. We're multiplying by 10 to the second power, so we're moving it over twice. Our decimal lands at the end of the number, so our answer is 1,457. In the number 4,234, our imaginary decimal is right at the end. We have to move it over 3 times to the right, so we have to add 3 zeros. Number, comma, number, comma, 4,234,000. Whoa, that's huge. 293 and 1/10. Put your pencil where the decimal should be. We're multiplying by 10 to the second, so we are moving it over twice. We end up with an answer of 29,310. And for this final, write all the digits first. Put your pencil where the decimal should be. We're multiplying by 10 to the second, so we move it over twice. Our decimal ends up at the end of the number, and our answer is 23,523. When we're dividing, we're going the opposite direction, so we're going to move it to the left. Write down your digits, put your pencil where your decimal would be. We're dividing by 10 to the second, so we're going to move it over twice, and add that 0 in the front. For 4,234, our decimal, remember, every number has that imaginary decimal at the end here. If we're dividing by 10 to the third, 1, 2, 3, we end up with an answer of 4 and 234 thousandths. Make sure your decimals and your commas are different and look different. Write down your digits, put your pencil where the decimal should be. We end up with 2 and 931 thousandths. And for our last problem, put your decimal where it should be. We're moving it over twice. And that's what our answer is. So again, you can pause this slide to read the directions, but this just goes over when you're multiplying by a power of 10, you're moving the decimal point to the right the number of places indicated by the exponent. For example, to multiply by 10 to the fourth, move the decimal point to the right 4 times. This works because the exponent tells the number of times a start number is multiplied by 10. Each time a number is multiplied by 10, the digits shift one place to the left, which moves the decimal point one place to the right. When you divide by a power of 10, you're moving the decimal point to the left, the number of places indicated by the exponent. So this is a great resource for you to pause if you need to help you when you're figuring out how to multiply or divide by a power of 10.